Let's continue our study of arrays of objects by predicting the weather. Here's our problem statement. Write a program that uses last year's temperature data to predict tomorrow's temperature. So let's talk a little bit about the difference between heuristics and algorithm. Heuristics are rules of thumb. They can be useful, but they don't always work. So you want to make sure that you know whether you're using a heuristic or not. Now, algorithms are different. Algorithms are a very specific computer science word. What they mean are sequences of instructions that solve problems. So if it doesn't work, if it doesn't solve the problem, it's not an algorithm. Now, weather prediction is not a problem we're going to be solving in this class. So you can guess that we're working with a heuristic here. And in fact, we are. So here's my weather prediction heuristic. To predict tomorrow's temperature, find the average mean temperature for the week centered on the same day last year. Now, if you don't like my heuristic, you can develop your own. So the first thing we need to do is to get weather data. Now, there is lots of weather data available on the internet. I got mine from wunderground.com, not claiming that's the best source necessarily. So I gave them a location. Then I scrolled down to find weather history and almanac. I created a custom report for Norman, Oklahoma, because that's where I am, on January 1st, 2013 to December 31st, 2013, and I saved it as a CSV file. Let me show you the process. First, we go to wunderground.com and give them our location, Norman, Oklahoma. Now we scroll down to find the weather history and almanac. So then we look at our weather history for Norman, Oklahoma. And we ask for a custom report. So we'll go from January 1st, 2013 to December 31st, 2013. Now this is going to create a giant table, and so we scroll down to the bottom and see that it will allow us to save it as a comma delimited file. That's another name for a comma separated values file. Now it doesn't actually save a file here. What it does is brings it up as a web page. So we select all and then copy it, and then we paste it into Eclipse as a file. Now it might be useful to also paste it into Excel and to create a comma separated values file there. Excel actually can read those files and it makes the computation a little bit easier. So let's talk about comma separated values files. They're a simple and general way to store data as text. As I said, Microsoft Excel can read them, which is a nice thing to be able to do. Now there is a format requirement. It has to be a uniform rectangular structure. So you have lines of data that are made up of fields, and the values in the fields are separated by commas. Now this means that the field values can't contain commas. So that's a problem if you want to store text, because commas are legal text. The other thing is you've got to know the meaning of the data to be useful. Now, our website gave us the meaning of the data, and we'll look at it more closely in a few minutes, so we'll know how to use the data. How are we going to read this CSV file? Well, the string class has a really cool method that we haven't used. Now, the reason we haven't used it is it uses an array of objects, and we didn't have that knowledge until just now. So the method is called split, and it uses something called a regular expression. Now, those are beyond the scope of this class, but it turns out that's the same thing that makes the scanner class work. They're really, really cool, but we're not going to study them. To separate a string by commas, the regular expression you need to use is just a string containing a comma. Now, I know that isn't very satisfying, but that's what we're going to go with for now. Now, the next problem we have is a very challenging problem involving testing. And that's that our program is going to find the day automatically. So if we use our previous strategy, we're going to have to wait and run it over a period of weeks or months, or in fact, almost a year. Right now it's January 6th, and so in order to test these end-of-year conditions, we would have to wait a year. Obviously, we can't wait a year to test a program, so we've got to think of something else. Now, in our previous programs, we always tested without making any changes to the program, and that is the gold standard. But we just can't do that in this case. Anytime we make changes, we're not testing the final program, and that is very dangerous. So what we want to do is to make the absolute minimum number of changes possible. Here's how we pull it off. We create a constant that says whether the program's being tested or not. So this would be a final Boolean. It would set testing, for example, now for true, because we're going to test the program first. Then we create a method that reads in the day from the keyboard if the program is being tested. So we'll call that something like public static int getDayNumber. And when we're finished testing, we set testing to false, and then we check to make sure it's working for today. So there's the strategy. It's not perfect, but it is how professionals solve this problem. The next thing we need to do is create our test data. Now we're going to need to test the program today, and we're going to have to worry about these boundary conditions. What are we going to do on January 1st? Well, on January 1st, we're only going to have 4 days of data. January 1st, 2nd, 3rd, and 4th. And that should work just fine. The same thing happens with December 28th to 31st. So these are definitely places we want to test the data. Now, we can use Excel to read the data and perform the calculations, and then document the test data in the file. I've actually done that process for you, and we'll review it when we get to Eclipse. One thing we might want to think about is what are we going to do about leap year? Well, this could be something that you make a big fuss about, but the truth is having one extra day in the year really isn't going to change things very much. You'll see that the temperature data tends to be very, very consistent from one day to the next. So I'm actually going to just ignore leap year. Now, there aren't many times that computer scientists ignore these boundary cases, but guess what? This is one of them. We're going to need to read the file. The parameter for that will have to be the constructed array. And then we're going to have to read the file name. We'll get a constant for that. And of course, the return type will be void because the parameter of the array will be returning the data. We're also going to need a method to calculate the temperature. So the array with the data will have to be a parameter. And of course, we'll need to know what index it is. And it's going to return a double with the average temperature. So let's go and take a look at Eclipse. The first thing I want to show you is the CSV data. Notice that here we have a date, and then we have the maximum temperature in Fahrenheit and the mean temperature in Fahrenheit. This mean temperature in Fahrenheit is the one that we want. So we can see this will be 0, 1, 2, the second element of that string array that split gives us. Now here's the test data that I created. Now to do this, I took the data in weather.csv and I entered it into Excel and used formulas. This isn't a class on using Excel, so if you're not familiar with Excel, you can do this by hand. But here are the values that we had. So now we have some good test data to run our program with. So let's go and write a little bit of our program. You'll notice that I've imported some classes, including some we haven't talked about just yet. Here's our main program. Here's a method that lets us get the day number. So this is the one that we're going to use just in testing. Now let's create our constant for testing right at the start. You'll notice I have a couple of other constants here. I have the file name called weather.csv, and I have days in year, which I've set to 365. Now I'm ignoring leap years here, and we might want to think about whether that's going to cause us problems later. So we'll have public static, final, Boolean, testing equals true. And notice that I've given some indication of what we're using that for. In our main program, we're going to say if testing. Now, a lot of beginning programmers like to write things like this as testing equals true, But that really isn't necessary, because if you think about it, if the variable testing is true, and apparently there it goes. So Eclipse is happy now. If testing is true, then testing equals true is true. And if testing is false, testing equals true is false. So in other words, testing equals true is exactly the same as just testing. So I prefer to write it this way. To tell you the truth, writing things like testing equals true make you look like a beginning programmer. Now, there's nothing wrong with that, but if you're trying to look like a professional, this is one of the ways to upgrade your code. So we'll call getDaysNumber, and we're going to need a variable day number to store it in. If testing is false, then we've got a little bit more complicated question, because we've got to figure out how to tell what day of the year it is. And this is something we haven't done before. So let's talk about how to get a day number. There's a class in Java called Gregorian Calendar. The default constructor uses the current time zone, and the locale. Now, locale includes things like the language. And the data for these are picked up automatically from the computer settings. So if you've never bothered to set your computer's time, you're going to get some funky data from this class. The get method in this class takes the name of the data you want and returns the day. So in this case, we're going to want to get Gregorian calendar dot day of year. Now, I would take you to the API to show you this, but the API is not particularly helpful in this case. The reason it isn't is because it uses a programming concept that we haven't encountered yet heavily. And so that's going to make it hard to read. So I guess you're going to have to take my word for it. So we'll do Gregorian calendar today equals new Gregorian calendar. So this is the default time, locale, and time zone. Then we'll do day number equals today.get Gregorian calendar dot day of year. Now, there's one slightly funky thing about this. And that is, as it happens, day of the year is unit indexed. These are the crazy things that Java does that don't really make any sense. Now, the only way you know things like this is to read the documentation carefully. And like I say, the documentation wasn't very helpful for beginners in this case. So what we're going to do is do day number equals day number minus 1. And now we're 0 indexed. Now we really might want to think about what we're doing here too. So for example, do we want December 31st to be day 365? If so, we better say it and then adjust this. Okay, now let's go down and make sure we've communicated that correctly. And let's actually put an example in. So we make sure we're communicating clearly with our user. Okay. So now we've got our day number. The next thing we need to do is to read our data from a file. So we've got our mean temperature array. Now, the reason I made it an int, you may not have noticed this when we were looking at the data, is that ints are what were stored here. And so that's why we have an integer array. So we have to open the file. We've done this several times, so we create a scanner with a new file. And remember, I had that constant file name. So we're going to, let's call it index. Create an index. It'll start at 0. And while index is less than days in year, you do mean temperature of index equals file.next. Oh, wait a minute. We can't use next int here. We've got to get the string that's the whole file. So we're going to call it string line equals file.next line. Then remember, we split the string apart into a string array. So I'll call that fields equals line.split. And remember, this is where we use our little comma separated value thing. So that's a regular expression we just used, even though we don't really know what that means. So once we've split this, then we know that our mean temperature is going to be fields of 2. Remember, of 2 because it was the third element on the line. Now the problem is that that is a string because it came from a string array. And so we have to change that into an integer. We know how to do that. Integer.parsing fields of 2. And of course, we need to increment our index. Okay, so we should now have our file ready to read in data. We haven't run our program yet, and it's about time that we do that. So let's run and see what happens. Enter the day number, and we can see that we've got some ugly input, so we need to fix that. So let's just try day number 1. Doesn't really matter what day. We need to think about the fact that we probably never called our get temperature from file program. We didn't test that part. So let's go and put that in the main program. Now this returns an integer array, which I'm going to call mean temperature. Oops, and that is not how that worked. Remember, get temperature from file took a parameter of the mean temperature. But we've got a problem because we haven't constructed the array. We didn't construct it in the main method, and we haven't constructed it in the other method. And that's clearly a mistake because we always have to construct arrays. Now, if you're wondering where split's array got constructed, it got constructed in the split method itself. And we could have done that here, but we haven't really learned that kind of programming just yet. So we're going to do our array construction right here. So here we construct the mean temperature array and then we read it in. Okay, so now that we're calling our method, we might see what's going on. You've probably guessed that I'm heading for a problem here. So the day number will be 1. And we crash and burn. Let's remember how to read these kind of errors. So we see a number format exception. So it took mean temperature F, and it's trying to change it into an integer. Notice we have integer.parseInt down here. And we can see that this is in the get temperature from file method on line 75. So it's told us very explicitly where our problem was. Notice that I do not explore anything that's in the Java API. Those classes are working correctly. We don't have to worry about them. I go to the topmost one that has the error message in it. So let's think about what happened. Well, if you'll recall, our file had headers in it. And since it has headers, that means that when we read the first line, we don't get numeric data. So what we need to do is to read in the header. So here we go. So this will be file.nextLine. Notice that I didn't save it anywhere. Now I'm putting that in as a comment that I skipped over the header. So when somebody looks at this, they recognize that that was a strategic choice and not just an oversight or an off by one bug. Okay, let's try our program again. Whoops, and I forgot to fix our input. Well, we'll do that in a minute. Okay, so now we have things being read in correctly. Incidentally, this input isn't quite so important because of the fact that it's just for testing. So that means our customers are never going to see this. Now, the next thing we need to do is to get average in the same week. Instead of returning 0, what we're going to do here is we're going to do int index equals day index minus 3. Because remember, we're going back 3 days to start. And now we're going to loop just 7 times because we want to get a week's worth of data. So we'll say while count is less than 7. And let's document what that 7 is. Well, we're going to need to store a sum. So we'll say sum equals sum plus mean temperature of index and then, of course, we'll increase our index and increase our count. And, of course, do a little bit of cleanup on our code to keep everything looking pretty. We need to think a little bit about this. Of course, we're going to have to return the sum divided by 7. Now, I know you're getting too wily as a programmer to make that mistake. So remember, sum is an int, and if we divide by another int, we get an integer, which truncates. So what we really want to divide by is 7.0, because this method is supposed to return a double, not an int. Okay, so what could possibly be wrong with this method? Well, we can run it and see. But first we need to call it in the main program. I predict tomorrow's temperature will be plus, so get average same week, of mean temperature and day number. Okay, let's run the program. Enter the day number. So we'll get 1, and immediately we get an array index out of bounds exception. Well, we probably should have anticipated that because we really thought about it when we were writing the test data. So we need to go back and rework that method a little bit so that it handles days correctly. So the question is, what happens here if the index is out of bounds? So let's put an if statement in there. If index is less than 0 or index is greater than days in year minus 1. Now we might want to think about whether we want to use parentheses there or not. Certainly parentheses are not going to do any harm. I'm not sure they do any good here because the precedence is actually correct. But let's put them in anyways to make the code a little bit easier to read. So what do we do if our index is out of bounds? Well, what we don't do is just try to add things on. We might think about whether this is the way we want to write the logic. So this is the logic for out of bounds. When we're out of bounds, all we do is going to be incrementing the index by 1. We might think whether it's better to write the logic for in bounds. Now we know how to do that because we know De Morgan's rules. So if index is greater than or equal to 0 and index is less than days in year, then we have a sum we can use. And of course, we'll need to indent this now. And we'll have a count. Now we want to increment the index no matter what happens to avoid infinite loops. So let's cut that line from there. End our if statement. And increment our index outside of the if statement. Now we also need to fix this because now we're only going to count when we actually have recorded a correct value. But we've still got that problem with integer division because count is an int and sum is an int. So here's another quick fix for that. We'll cast count to double. Now you have to be careful with casting to make sure you do it in the right place because you want to make sure that the cast gets done before the division. By putting it next to count, there's just no other way that could possibly happen. So there we go. Now let's see if our program is working a little better. So for the day of the year with 1, well, 34.714. So let's go to our test data and see if that's correct. Uh-oh, for January 1st, we were supposed to have 32.667. Got to think that one through. So the first thing we might want to think about is day index minus 3. Was that the correct number? So if we started, for example, at day index is 0, this would go to -3, -2, -1. That seems right. We also might want to look and see if we took the correct index. And it looks like we did take the correct index. And we've incremented count correctly and incremented the index correctly. So that's sort of strange. We may need to use some of our better debugging techniques to work on this problem. Let's think through our indices first, because remember, reading code is always a good place to start. So if we had get days number returning 1, this day number should have been 0. And so that looks correct too. We skipped over the header. That was correct. You know, one thing we might look at is whether that value was the same as another value. For example, 34.714 is the January 4th total. Now that suggests that maybe we've made another mistake. The question, of course, is whether the mistake was in our interpretation of the data. For example, did we create the correct data or not? So let's go and check the data first. Our temperatures, remember I'm reading the third field here, were 30, 35, 33, and 32. Those are the 4 that should have been averaged. So we've got 30 times 4, that's 120, 125, 128, 130, and then we're dividing by 4. So when we divide 130 by 4, we get to the point where we need a calculator. $130 divide by 4 is 32.5. Let's check our test data. It says 32.667. So let's think again. 30, 35. So you add those two together, you get 65, 98, 130. So we found an error in the test data. That happens sometimes. Probably my finger just slipped when I was creating a formula in Excel. But that still doesn't make our program right. So let's go back and look at the computation again. Let's look at this get average same week method. Now the count starts at 0, and while the count is less than 7, then we add to the sum. Well, if you think about it, since count only gets incremented then, what that means is we've got the wrong test on the loop, because we've averaged 7 days whether there were 7 days or not. Now, how I figured this out was because of the coincidence of having 34.714 being the data. Because we could see that that data was there, we could see that what the problem was that we had shifted the data off a little bit. So now we have to figure out how to fix this. So we might want to think about whether we want to count here based on count or whether we want to count based on index. So we have to do something different here. So let's say while index is less than day index plus 3. Now let's think this through carefully this time, because we don't want to be off by 1 here. When it's equal to day index plus 3, do we want to go through the loop or not? Well, that's 3 days after, and yes, we want to go through the loop. So that should be less than or equal to, not just less than. So let's run our program again, now that we found not 1 but 2 mistakes, and see how things look. So here's the day number, 32.5. 32.5, that's looking good. So let's run our other values now and see if they work. So this will be day 2, and we get 34.0, and we run again. Day 3 will be 34.5, that's looking good. So apparently whatever I did wrong in that test data formula, I only did wrong once. 34.714, looking good. Now we want to test for today. Now this is the 6th day. $37.857, that looks good. Now for this December dates, we need to think about what days they are. So let's actually add to our test data. This is day 365. So this must be day 364, day 363, day 362. Okay, so now we have the day numbers. So 362 will be 36.5. That looks good. 363, 37, 364, 36.75. Apparently I did some rounding in the data. And 365 will be 34.333. Now that one looks a little suspicious too, so let's go and check our data one more time. So that's just the last 4 days of the year, which would be 46 plus 31 plus 26 plus 37. 46 plus 31 plus 26 plus 37. And then we divide by 4 and we get 35. So that's kind of strange. Well, let's think about what's going on in this loop. Do we have another off by 1 bug? For example, do we really want index less than days in year minus 1 or index less than days in year? Well, if you think about it, when index is less than days in year, it's less than or equal to days in year minus 1, which is the last element of our array. So we've made a lot of mistakes in this calculation. Let's run it again and see if things are looking better. So let's start at day 362. 36.57. So notice those little errors that we were ignoring were actually bugs in the program that we almost missed. Now, since programs like this are just for fun and games, it's not so bad. But they still should be right. Remember, that's a matter of professionalism. And notice things are now working absolutely perfectly. So you've now used a computer to predict weather. So keep programming.